Okay. First of all, we need to write this one. We need to talk about the basic variable types. For this lesson. Okay. Now, first of all, we need to say what is a type. Type is a feature of variable operators applied to variable and values stored in it. Okay. In Python, every variable has an associated type which defines to what? First of all, the range and kind of data it can store. Okay. Secondly, the operations that can be performed on it and how it behaves in expressions. Unlike C or C++, the types in Python are bound to the values, not the variable names, which means that we can assign to the any variable to the another one. String assigned to the integer assigned to the double or the numeric values. Okay. But you need to know that the standard built-in variables types in Python can be given by the integer, float, bool, str, string, non-type, and the complex. These are the built-in or the default types of the variables. Okay, and also all of these are implemented as classes internally, which we will debate about it. Okay, and so we can say that everything in Python is an object. Okay. But we need to write or talk about these variables. First of all, the integer. Okay. What's the integers? Integers represent the whole numbers. Positive, negative, just like in the C++, without a fractional components. Okay. And also Python automatically handles arbitrary length integer. You don't need to define the integer 64, 32, 8 or another else. Okay. And so which means that we don't have any overflow like in C or C++ because we don't have any keyword related to the integer in that case. Okay. For the example of these terms, a is equals to the 5. Okay, we can print the what the a is equals to the what the 5. If you want to know about any type in here in the Python, we can use the type built-in function, just like this one. See, this is the class of the int in here. But if I use the 5.2, and so this returns to the what the float values of these terms. Okay. We can be sure about the type of the integer in here. With the same idea, we have the float point or float types in Python. This is shortly represents to the what the real numbers with decimal points, floating point representations. Okay. Internally, this uses the IEEE 754 double precision format, which means that 64-bit format is default in Python. But you must be aware of a small running errors due to the binary floating point representation. For example, if we have the print 0.3 minus 0.2, and so if we are running this code, and then this is called what, 0.099999 and 8, but the answer is simple, 0.1 in here. But you should be aware of these properties, and this is an error case, but in the runtime error case, okay, due to the floating point precision, we can see to the what, 0.099999 blah 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 and 8, okay. These are the float type. And the other type of this code is the Boolean. What's the Boolean? Boolean means that represents to the what logical truth values, true or false, subclass of an int. In C++, we don't have the Boolean type, but the Boolean type is interpreted in the what? In terms of the integer values, zeros and 1 in C++. But in the Python, we have the different class returning values with the what? With the bool values, true or false. Okay, but it can be converted into the what? Into the integer values, which will we create the example session about the next week, I think. Okay. For example. Here, if we have properties, and so the print 0.3 minus 0.2, which is equals to the 1 in here, the output is false. Just see, this returns to the what? The conditional statement, or the whether the true or false, because it's a comparison operator which is in here, okay? Or 0.1, which is equals to this one, and so this is also false. Or we have the parenthesis operator in here, just like this one, and so we have the false, because this is the what? This is the due to what? Floating point precision. Okay. No, Ayşenur, we don't have this kind of properties because you need to give some precise precision values of these terms in here. This is an error case which I'm using in this case right now. Okay, just see that if this is the case, we can copy all of these terms in here, just like this one. If I run this code, and then we have these terms in here. In order to do that, we need to cast the float values in here, just like this one, and so this also float. But if we are using the integer case, and so we can convert what? Zero values, okay? And so, Ayşenur, if you want to do this, in this case, we don't have the precise values. This is equals to 0.2, but in the Boolean case, we have the error case, which I'm using in here right now to learn about it, okay? This is the answer of your question. So, what is the result of these terms? To print true plus 3. See, this is a 4. But why? Because the Boolean is the subclass of the integer values, and so we can produce or the sum or the multiply with these terms with the what? With the Boolean values. And so Boolean and integer happens because it inherits from the integer values, guys, okay? The automatic conversion can be handled by the Python program language, okay? And this is also arithmetic operations. True behaves as the 1, true 1, false as the 0. Okay, just remember that. So we have another different data type, which we call it the string or str. Okay, in C++ programming language we don't have the string default values, but we have the char type, right? But the char is a subclass of the integer in the C++. But in the Python, we don't have this kind of mechanism. Okay? So, the str represents a sequence of Unicode characters. Okay? And also, str are immutable once created character, and they cannot be changed in memory. These are the important properties, especially for the system dependent or the cross-platform implementations. Okay. So the example of it, just like this one, we can create this example. S, for example, is equals to the Osman, and so we can print the Osman just like this one. Osman is seen here, and also we can assign to the Emre. Emre. See? The right hand side of these values are immutable in this case. And also the str, just like another data type, these are called the class structure variables. And so, which means that these variables have another variable or the properties with the function or the methods that will be talked about in the 5th or the 4th weeks in our lesson. Okay? The useful methods can be created the upper, lower, or split, or something like that. For example, we can define the Mehmet in here, and so we can reach S dot in here with the upper, and so it returns to the bigger Mehmet in here at the characters. These are useful properties, guys. Okay. So we have also a non-type in Python program. Non-type. What's the meaning of the non-type? Non-type means that it's just like the null character or the null value in C or C++ programming language, guys. But it's a class. The absence of a value or a null reference, guys. Okay? And it is a special singleton object of type non-type. Okay, commonly used to indicate no results or nothing returned values of these terms. In the example case, we can write the x is equals to the none. Okay, we can assign it, and so we can print the x just like this one, and so it returns to the none or no one or nothing. Okay. Or we can search for the type of the x just like this one, and so this is the class of non-type. Okay, this is just like the null character in C or C++ programming language, but in the Python we have the dynamic type memories in here, which means that we need to define a class to represent the nothing. Okay. So we have one more class or the basic data types, which is called the complex numbers. This is a default class to handle complex numbers. This is represents complex numbers in the form of just like this one, a plus bj. Okay, j is the imaginary units. And the example can be given just like this one, the print or z is equals to the what? Minus 1j plus 2. In C++, we have the syntax error at this case, but in the Python this is a default type, and so if you run this code, 2 minus 1j is given in here. Okay, and also we can reach to the what, the z real parts or imaginary parts. Okay, 2 minus 1. These are the uses, and the complex number are first class citizen in Python, unlike the C++ case, because in the C++ we don't have kind of operations or the classes which we need to create. Okay, they require the complex header or the user defined structure. Any question? If you don't have any question, and then we need to continue with the what? The creation of the variables. Creation of variables. We need to talk about it. Okay. Creation of variables. Firstly, z is equals to 5. Python sees that code, z equals to the 5, or the assignment to the 5, automatically assigns the type based on the right hand side value, which means that if we have the right hand value, in this case we have the 5, the default type of the 5 is integer, and so automatically this assignment operator initializes the z with the type of the integer. But if I using the 5.2, and so this is initialized with the float value. Or we can say that in the Python, the right hand side defines the type of the variable, unlike the C++. Okay? So this has a special name, the type inference values, or that happens dynamically when the assignment occurs. Okay? This is the creation of the variables. Otherwise we cannot create the variables just like this one. Okay? But in order to create any variables in here, we should use this assignment operator, or we can create the empty variables with the class of the integer. These are two syntax and semantically valid comparison, but we don't have any knowledge about the classes right now, and so just you know that if we want to define or create the variables, we need to use the assignment operator, just like this one. Otherwise we cannot do that. So this is the creation of the variables. After that, in order to create the variables, we need to talk about the literals, right? Just remember that the literals are constant values used directly in code without computation, which means that these are the constants, and we can create it in the form of the integers, floats, strings, and the booleans. For example, 1, 2, 3, 1.5, or 2, 2.2. This is the what, or Mehmet. This is the integer literal. This is the float literal. This is the float literal. This is the str literal. Okay? And so these are the constant values, and they have possessed a constant address on these terms. And so if we want to create any variables, we need to use the literals always in that case. Okay? Any question? So, if you don't have any question, and so we need to give the some summary until now. Okay? Summary. First of all, 1. The Python variable types are not declared explicitly. These are determined at runtime. Second, every type is an object derived from its corresponding classes. Which classes? Integer, float, bool, etc. Okay? Python automatically manages type creation by looking with what right hand values of these terms, and conversion is automatic, and also memory allocation. This is called the dynamic type memory system. These are automatically handled by the Python interpreter, guys. Okay? Unlike C or CPP programming language, no manual type, declaration, or conversion can be added or they're required unless desired, which is called the creation of the class, but our own class. And also finally, the strong yet dynamic type system provides to the what? Both flexibility and safety, guys. Okay? These are the important parts of these terms. Okay? Any question? If you don't have any question, we need to talk about the important part of the Python, the meaning of the address concepts. The meaning of address. As anyone knows about the address concept in C++ programming language, guys? Can anyone say that? What's the meaning of the address? I'm waiting. Could you write it to the chat? Yes, again, a place in the memory. But where is the memory? What's memory on your computer? CPU is not a memory. Yeah. Hard drive or RAM or ROM. Yes, it's RAM. Very good. In order to understand the concept of the address is important for dynamic type of the systems, especially for the what object-oriented programming language, because the C or C++ possess the what the address notation or the operators for this kind of definition, int star or double star. Asterisk operator can be used in C or C++ programming language to create or reach the address values or the assignment of these terms. But the Python, we have different properties. First of all, we need to talk about the CPU. Okay? What is the CPU? CPU, computational power units, or central processing units, can be seen in here, that performs the whole arithmetic, comparison, and bit level operations via logic gates. Okay, because the CPU executes the whole mathematical and logical instruction, guys. However, It does not permanently store variable values. The role is convert or the depends on this case to the what that the role belongs to memory, which is called the RAM. Okay, random access memory. So what is the meaning of this in Python? Which is the all high level languages. What's the meaning of the high level? We don't see the address registers or the memory operations at the high level language. Variable data is stored in RAM, okay? And CPU fetches these values using their memory address. These are informed from the what? From the computer or the machine language, okay? During instruction execution, guys, okay? What's the meaning of this? For example, I can explain it. A is equals to the B plus C, okay? First of all, the CPU takes the values of B and C from specific memory locations, which is called to the RAM, okay? And after that, it performs the addition operation internally. This is included in the CPU, okay? And then it stores the results, which is equals to what? To the A in the another location in RAM, guys, okay? Associated with the variable of the A, okay? But how does CPU access these values? Via address notation or the address values of these terms. Otherwise, we cannot know the which variable or the literal that can be stored at the which address point. So these are the identifier for the memory locations. And so each variable name like A, B, C in that case is mapped into a specific memory address where its value resides, okay? And so this address serves as a pointer, just like in C or C++, a numeric location index in physical memory, which means that RAM. So therefore every variable in Python or the other language has a unique address location in memory and a value, the data stored at that address. Otherwise we cannot read or we cannot write to anything to the what the computer structure, guys. The CPU always works on the values fetched from memory using this address. Okay, so we have two important properties: a unique address, a value stored, and CPU computes or process these terms. Okay. Any question? If you don't have any question, and then we will continue with the meaning of the variable again. Variable. First of all, we need to give some general information about it. The programming languages that possess a dynamic type system, like Python. All variables are essentially reference pointers that store the address of the actual data. Which means that when a variable is created, the interpreter allocates a memory block in RAM. After that, associates that block with an internal address, or in Python, object ID. Okay, and the variable name itself only points to that memory address, not the value. Which means that if we assign any variable or any literal to the specific name identifiers, just like x, a, and so we just only transfer or pass the address values of these literals to these variables, not the name of it. Okay. So in Python, in conclusion, just like we have some conclusion about it, every value, number, string, list, etc. is an object stored in a memory, which means that the variable names act as labels or reference that point those objects, which is called the pointer. But in the Python we cannot do that. We don't have any pointers in here, and so if we don't have any pointers, the interpreter must be run in here. The interpreter manages the underlying address object mapping automatically. Okay. So when we use variables created in Python, we actually use the values stored in the lam location, which is called the address. Okay, not the raw memory address of the variable, which means that the address is handled internally by Python memory manager. We can still view it using the built-in ID function, but just see that if a is equals to the 10, so we can print the a, but where is the location of the a, which is stored in the RAM, right? 10 and a stored in the RAM. But how we can reach the address values of these terms? ID a, which is equals to the what? 140 blah 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 24. Okay, these numbers are the address location at the memory of the RAM. In your computer, if you run this code, you have the different properties or the different address location for this case. But in my computer, and so these addresses are given in here. Okay. But what about this one? ID 10. What's the result of this code? In Python, we have the beautiful interpreter. If we have the any literal with the name of the 10, and also we have a point, so this Python sees only the address location. Otherwise, these two numbers are different, must be different in this case. But the 10 and A have the same memory location of your physical memory. This cannot be happened. But what if your variable is just only a reference point to what to point the some address values? In that case, the 10 is stored the memory location and A is pointing that 10 by using the address. So in this case 10 is stored, not A. This A is just an address masking with Python. Do you understand what I'm talking, guys? These are the important properties. If you understand the concept of the address using in the Python, you can create the strong computer programs, because every properties which is given at the RAM locations or the address locations. Okay. If you understand these terms, what if we add another? I think Mustafa, you said this one, right? Mustafa, this is your question? Okay, these are the same. Because only 10 exists in RAM location, not A, not B, not C. Because the RAM stores the literals, not the variables. These variables are the address indicator or pointing to the what the some literals. The Python is based on these concepts. Otherwise, we cannot create the dynamic type of these terms. These are called to the what the pointers in terms of the Python notation. Okay? Do you understand that? Okay. So we have some questions in here. What happens when an integer variable is assigned to a float one? Which means that these are question. A is 5, B is 2.2, and B is equals to the A. This syntax is correct. Okay. Here, in another case, the reference stored in an A is now assigned to B. This means that both names A and B now point to the same object, integer 5. In this case, no new data is copied for this case. Only the reference address is passed, which means that we don't have another address pointing here just like this one. The A pointing to the 5, B pointing to 2.2, but at the end of this case, the B possess to the 5 value. But how can we convert that? Because this is the integer value, this is the float value. We cannot do that in the C++ programming language, but we can do in this case because we have the dynamic type system, which means that we create dynamically literal values on our hardware. And the variables is only pointing or the reference address of these literals. For example, 5, 2.2. Okay? These are the important properties for this case, because in this case ADA and ADB has the same address. And what's the result of this term, AD5? Is it the same or different in that case? Ayşenur. Yes, same. Why? Just repeat. Why are the same? Just tell me. You can speak or you can write. It stores always, right? Because the literals only stored in the RAM, not the variable or the variable address. And so A, B are just a mask for the what the reference address is passed into the what into the distance. In contrast, in C or C++ programming language, assignment between the variables may involve copying the values of itself because it has also a pointer and a normal variable types. But in Python, it's a reference reassignment by default. Okay. These are the important properties of these terms. Please just test it on your computer. And so, in the second question, what if we assign a new literal to A afterwards? Which means that the case is just look like this one. 1, 2, 3, B is equals to the A is 4, 5, 6. Okay? In that case, just now, the 1, 2, 3 is different from the 4, 5, 6. Okay? And so 1, 2, 3 and 4, 5, 6 are stored in different RAM location because it's a new object is created. And the A points to the 4, 5, 6. Right? B still points to the old object right now. Or not. So, print ID A, print ID B. These are different or not? Ayşenur Özkum. Just tell me. The address locations are different or not in this case? Not. Why? Why? Just turning to the same. No. Just see that. In this case, we have the 1, 2, 3 and 4, 5, 6. The print ADA, A is pointing to 4, 5, 6, but B is still to the what? The 1, 2, 3. Okay? These are the difference. Okay. Let's take a break for 15 minutes and then we will continue with the concept of the address. Okay?